Hi, I'm Robert Moncrief, President of H2O Engineering, located in beautiful San Luis Obispo, California. For those of you who do not know about H2O Engineering, we are an ozone system integrator for the water treatment industry. We began building ozone systems in 2000 and have successfully earned a position as a leading equipment provider for groundwater and soil remediation. In addition to remediation, our equipment translates really nicely into both water reuse and produced water industries. Today, I want to show you one of the most advanced ozone systems that we have built to date. This is a 200-pound ozone system that we have designed for a customer and project in New Jersey. This container is one of 5 containers for this project. This is the air center. This is basically where everything starts. First, we have here what's called our feed compressor. It's a 100 horsepower compressor and does 415 CFM at 125 PSI. So this feed compressor feeds the other 2 containers on the other side of this wall oxygen generating system. So it's delivering dry, clean, cool air to the oxygen generators. So this is the big compressor in the air center. This is the blend compressor. It's 125 horsepower and delivers 560 CFM at up to a maximum of 125 PSI of airflow to our 2 manifold enclosures. So that air from the blend compressor will come into the storage tank and then go through our piping to the outlet out to the manifold enclosures. And on the piping, what we did is we actually installed flow indicators and transmitters. So that way, the control system will actually be able to do a digital display readout for flow going to the manifold. So that way we can verify that there is flow coming from the blend compressor. So we were just in the air center, and now what I'm going to show you is these 2 enclosures. This is ozone A and ozone B. This is basically where the heart of the system is. This is where the ozone is being generated. So you can see that the feed gas compressor is delivering the feed gas to the oxygen concentrators inside the ozone generator. So on each enclosure, what we've done is we've mounted an external control panel. So that way when the operator walks up to the site before entering into the ozone enclosure, he can actually see any conditions or status conditions of how the system is actually functioning or operating. So you could basically tap on ozone A. You could see basically a process flow diagram of measuring pressure, flows, O2 purity, ozone output in PSI, and ozone pounds per day. So here we are in enclosure A. It's the ozone A enclosure. So this is where we're generating the ozone. Again, what we do is we bring in clean, cool, ambient, or dry air from the air center into our air receiver tank. From here, we then go into our oxygen concentrator. This is a pressure swing absorption concentrator, and again, what we're doing is just separating out the nitrogen and concentrating the oxygen in ambient air. So this particular system will deliver 840 SCFH at about 40 PSI of 93% purity oxygen to our ozone generator. So this is the ozone generator. This is the heart of the enclosure ozone system. This particular ozone generator is a peak series ozone generator from Pinnacle Ozone. It features the quad block design, which is the latest cutting edge in ozone technology. These are what's called the quad blocks. Okay, again, this particular system does up to 100 pounds per day. This quad block peak series ozone system is designed with actually 5 quad blocks. So they each produce 20 pounds of ozone at 5% by weight concentration. This system is built with an onboard ambient oxygen sensor, an onboard ozone sensor, and then has specific diagnostics to completely monitor itself. It's a water-cooled ozone system. You can see the manifold here. The power usage is the lowest in the industry, and by containing all of the high voltage on the quad block, the losses are minimized, so there is no danger of exposure to high voltage. So from our ozone generator, we then go into our ozone delivery pumps. So again, what we're doing with our ozone delivery pumps is we're actually boosting the ozone gas flow to overcome the sparge pressure in your formation. These ozone delivery pumps each have 8 heads. They consist of a Teflon diaphragm and stainless steel wetted parts. We've put the ozone delivery pumps on a rack mount system so that we can easily come in and service the ozone delivery pumps. From the ozone delivery pumps, we go into a pressure and mechanical flow indication, and then out of the enclosure over to the 2 manifold enclosures. So here we are at the 2 manifold enclosures. These particular enclosures will be located between 400 to 600 feet away from the ozone enclosures when the system is actually on site. Each enclosure features, again, a human-machine interface or operator interface. So the technician on site can actually go to the panel and actually view the enclosure and all the process indicators that are going on inside the enclosure before entering. So we are in the larger of the 2 manifold enclosures. This enclosure has 8 legs with 35 laterals for a total of 280 Sparge Wells. So the operator can program 35 laterals to run at once per leg, or he or she can mix and match each lateral or each leg. So each enclosure has a safety door switch on all doors and an operator interface, an emergency stop, and then internal ozone sensors. So key safety features to each enclosure. And also in this enclosure, since this is the largest one, the client asked us to incorporate a soil vapor extraction manifold. So here we are in the smaller enclosure, and let me go through a little bit of the process flow. This is our air blend coming from our air center. This is our ozone coming from our ozone enclosures. So we blend the 2 gases right here, and we go into, again, our 8 legs. The smaller enclosure here has 17 laterals per leg for a total of 136 Sparge well capability. This system again incorporates internal ozone sensors and an operator interface and electronic door switches for any door switch alarm. So there you have it. We are very excited about this technology and what it can be in the future, so hopefully you will be too. Thank you very much for your attention and considering H2O Engineering.